Since we're finding tangent lines on ridiculously long problems here to use implicit differentiation, I thought I would just show you what this function looks like. Is that not beautiful? I think it's called a cartioid or a carotid. I always get them mixed up. It's a beautiful function. And in order to find a tangent line, well, we need the slope at that line because we're going to ultimately have a y equals mx plus b. To get the slope, we need to take a derivative. So we're going to use implicit, and we're going to work it out. And I think the easiest thing to do here is to FOIL this out. Instead of using squared there, I think we should. So what I'm going to do is write 2x squared plus 2y squared minus x. I'm going to FOIL it out on this side. And then we'll do it. So it's just easier that way for me. You can do it any way you want. 4x to the fourth. I'm going to do this one. Plus 4x squared y squared minus 2x cubed. I can already see we're not going to have space. Let's just bring this over right now. What do you say to that? Like that. Did I lose anything there? I don't think so. I'm going to leave the x squared plus y squared. Okay, let's do the next part. 2y and 2x squared would be a plus 4x squared y squared. A couple of 2y squareds is going to give you a 4y to the fourth. And this one will be a minus 2xy squared. We need even more space, I think. I'm going to move everything over to the left a little bit farther. This is going to hurt. How did Seinfeld say it? This is going to be a shame. Minus 2x cubed minus 2xy squared plus x squared. I think that's right. Oh, mercy. All right, can any of these be combined first? Well, x to the fourth. Here's an x squared and a y squared. Here's an x squared y squared. Is there any other x squared y squareds? There's not. So let's believe me, if you do it now, it'll be less later. So we'll do 4x to the fourth, and then I'm going to cross these out as I go. That's how I keep track. Plus 8x squared y squared. It just feels good to erase them, I'll tell you that. Here's an x cubed and an x cubed. So we'll do a minus 4x cubed. Please don't make me have to do this a few times by doing it wrong. Here's a couple minus 2xy squareds. So let's put that in there. Minus 4xy squared. So that's out now. Then we have a plus x squared and a plus 4y to the fourth. Those look like all of the things I can do for now. So I guess we can take the derivative next. Well, we can move these over. Here's an x squared. Let's subtract that out. So that's out. And what about this y squared here? I guess he's fine where he is. Now we'll take the derivative. This is as simple as I can make it. So it's 2y, but y is a function. So after the power rule, you have to use the chain rule, dy dx. Equals 16x cubed plus, this is a product rule, u prime v plus v prime u, and we'll put an 8 in front of it. So that would be 2x y squared plus 2y dy dx, chain rule, x squared. Minus 12x squared minus 4, chain rule, or product rule, u prime v plus v prime u is x is 1, so we just get y squared here, or the derivative of x is 1 to get the y squared, plus v prime, which is 2y dy dx times x. And then we have plus 16y cubed dy dx. Mercy. This is a tough problem. I shouldn't say tough problem, it's a long problem. So I'm going to circle my dy dx's in here, because I want them all on one side, right? Or left. So 2y dy dx, and this is a 2x squared y, but also the 8 outside, so we'll call it minus 16, so we're subtracting it to this side. Pardon that noise. 16 x squared y dy dx. This one is going to be a minus 8, so we'll call it a plus 8 when we bring it to the other side. 8xy dy dx. And then this one over here is a minus 16y cubed dy dx equals 16x cubed plus 16xy squared minus 12x squared minus 4y squared. Let's take the dy dx out. I am a human computer. That was a really weird thing to say, I know. But sometimes you're writing so many numbers that it just kind of makes you wonder if you are actually an android. And I know I'm human because I'm going to get this question wrong. So what's that give us for our dy dx? We get 16x cubed plus 16xy squared minus 12x squared minus 4y squared over 2y minus 16x squared y plus 8xy minus 16y cubed. Everybody get that? We can take a 2 out. We could take a 4 out. We can take a 2 out. Okay, so we'll call it 8x cubed plus 8xy squared minus 6x squared minus 2y squared over y minus 8x squared y plus 4xy minus 8y cubed. So here we found the derivative. Well, that's going to give us the slope of our tangent line, so let's come up here and try and remember what we're doing. We're at the point 0, 1/2, so x is going to be 0. Thank you, good Lord. So this is out, this is out, this is out, this is out, this is out. So what does that condense down to? Negative 2y squared over y minus 8y cubed. We'll cross a y off of that. We'll make this a 2, we'll make this a 1. So we get negative 2y over negative 1 minus 8y squared. And y is 1/2, so negative 2 times 1/2 would be negative 1 over, what's 1/2 squared? That's 1/4. 8 times 1/4 is 2. 1 minus 2 is negative 1. So do we get a slope of 1 after all of that? So we get, for our tangent line, y equals x plus b. And we know that x is 0 and y is 1/2. So b should be 1/2. So I think our tangent line is y equals x plus 1/2. This should be the answer to the question. And I plotted it. And I got to tell you, I don't hate the idea because this is at 0. I'll write it outside of the graph. This is at 0, 1/2. So I'm thinking this is the x-axis. This is the y-axis. I can believe that. That looks like a slope of about 45 degrees. A slope of 1 should be about right. So by inspection, this does appear to be correct. Is that not a beautiful graph? I really like this problem, to be honest with you.